Rapid developments in robotics and artificial intelligence are ushering in a new age that could profoundly change the way we live. From smart houses to self-driving cars, the applications of AI and robotics are virtually limitless. The construction industry is by no means immune to these developments. It's an incredibly exciting time for our sector, as numerous pioneers and research teams develop robotic technology to take over dangerous or highly repetitive tasks, improving quality, productivity, and efficiency. Here, we delve into the roles that robots are starting to play in construction and look at how they will affect our industry in the future. Before we start, it's important to be clear on the difference between a machine and a robot. While all robots are machines, not all machines are robots. Ultimately, what sets a robot apart from a machine is its ability to be programmed to undertake complex tasks and to operate, at the very least, on a semi-autonomous level. While a worker lifting a heavy load with an exoskeleton might appear robotic, the process is still controlled and operated by the worker. The same can be said for drones. Though they are able to carry out a series of tasks, at present most commercially available drones are controlled remotely and are unable to perform those tasks without human interaction. Arguably, the most prevalent type of construction robot at the moment is the mechanical arm. While stationary versions of these robots have been in operation in factories and on manufacturing assembly lines for years, portable adaptations are now being developed for use in all manner of tasks on construction sites. Able to be programmed to perform a range of repetitive and labour-intensive activities, such as moving materials, tying rebar, building masonry walls, and even 3D printing structures, these robots are set to have a huge impact on the industry, reducing accidents and greatly increasing productivity. One particularly prominent example is Odeco Formwork Robotics, who have developed a robot that uses hot wire cutting to develop complex double-curved concrete moulds. Traditionally, this time-consuming and costly process was used sparingly in construction. Now, these robots can be programmed to create intricate formwork moulds with a higher degree of accuracy than a human worker and in a fraction of the time, unlocking complex designs and helping to make them a reality. This particular robot looks set to work on Zaha Hadid Architects' Lushan Primary School project in China. Meanwhile, in bricklaying, SAM 100, developed by Construction Robotics, claims to be the world's first commercially available robot for on-site masonry construction. There's also Hadrian X, developed by Fast Brick Robotics, that can 3D print and lay bricks, completing the superstructure of a conventional masonry home in just 2 days. In the world of steel reinforcement, TieBot, a robot developed by Advanced Construction Robotics, has been trialled tying rebar on a bridge project in Pennsylvania, one of the first examples of a robot undertaking activity on a live construction site. There are also rapid developments coming out of ETH Zurich's National Centre for Competence and Research, Digital Fabrication in Switzerland. Researchers here have developed in-situ fabricators that can build masonry walls, construct steel reinforcement structures, and even assemble timber frame buildings. Robots are also entering construction in the form of autonomous rovers equipped with high-definition cameras and sensors that allow them to navigate their way around sites. Able to identify and avoid obstacles, robots such as EffiBot, developed by French robotics firm Evidence, can follow workers carrying tools and materials. Even more advanced is this rover by Doxal that uses high-definition cameras and light imaging detection and ranging, or LiDAR sensors, to carry out building site inspections, comparing progress with design models and programs. Moving things up a gear, complete autonomous vehicles and plant are able to transport materials or undertake specific tasks in accordance with design models. Activities like excavation or grading can be carried out around the clock without the need for breaks, greatly enhancing efficiency and reducing costs. Prominent examples include Volvo's HX1 dumper